to give me the chance and opportunity to present myself. And it's a very different topic that we have been listening since morning. What does sleeping brain do to our brain and body? If I ask a general question, I assume that most of you will give answer, it gives rest to our body and brain. This is I'm going to talk about is not only the answer, you may get a different answer today. Does it help our memory consolidation? So I'm going to talk about the associative conditioned memory. So associative memory, let me give you an example. If I ask you to turn on this electrical switch, if it is broken, are you going to turn it on? Answer would be no. And if I ask why, the answer would be that you may get shocked. But the broken switch is not the marker of shock. You are not touching whether it's broken. You don't know whether there is electrical current or not. So this is an example of associative memory where some clue you get to memorize that something else may happen. So in the animal model, I'm going to show you how sleep helps us to consolidate memory after training. That is very much important. So there are a lot of research that suggests sleep play important role in memory consolidation, especially to the skill memory. And there are other reports that say when you learn, especially the processor skill memory, sleep architecture changes. Means that we have two different kinds of sleep, non-REM sleep and REM sleep. REM sleep where most of the time we dream, and most of the non-dreaming phase is called non-REM sleep. And 80% time we spend in non-REM sleep, only 20% in REM sleep. Full form is rapid eye movement sleep, a sleep stage where eyes are moving a lot and our postural muscle gets similar to a paralytic condition. So we can't able to move our posture. In the non-REM sleep, that is 80%, that doesn't happen. So non-REM and REM sleep gets augmented in some form after learning. And it has also been shown that sleep deprivation, if you don't allow someone to sleep after learning, next day if you ask them to perform, they are not able to perform accurately. Means that suggests that sleep plays some kind of important role for memory consolidation. But what happens to the conditioned memory, that is not known. That was not known, and we have shown for the first time it also plays an important role for the conditioned memory. And since sleep deprivation, you may feel that it's a stressful situation, and whether it is a sleep or without sleep or it's a stress, that was always criticized because you cannot eliminate a stress factor if you are doing sleep deprivation. So we have also shown for the first time here that it's not the stress-related phenomena, rather it's a sleep-dependent phenomena. So today I'm going to talk about that consolidation of associative memory alters sleep architecture. That is true. Second, altered sleep architecture is an explicitly consolidation-dependent mechanism. If you don't allow memory consolidation to take place by using some kind of protein synthesis inhibitor, then sleep architecture doesn't change. And third, sleep deprivation does induce impairment in the consolidation of memory. So I'm going to show you the small video here. That is what the example of associative memory is. So here this light is on, and animal will be given fruit juice after a certain period of time. So animal learns, this light is off. Now you will see here the juice is there, and every time animal enters their head to get the juice, computer registering how many times animal has entered into this. So this kind of sequence we allow, and you can say this animal is learned, will never move anywhere, but will be sitting next to there, and they are waiting the turn, the juice to come. So this kind of training we gave, and after the training, what we did, this is what the response is. Training, there's a number of head entries to get the fruit juice. Testing, significantly high. And after that, the training and testing, we recorded sleep architecture. We can record sleep, and we can analyze non-REM sleep and REM sleep. So non-REM sleep, that is 80%, didn't change. What changed? REM sleep, dreaming condition. And REM sleep, there are two parameters. Either REM sleep length will increase or animal will go more time into REM sleep. So that is the number of REM sleep episode. That number of REM sleep episode that got significantly increased just after training days and testing days. Now, what we did, N-isomycin, you must be knowing, is a general protein synthesis inhibitor. Just after training, we injected N-isomycin, a protein synthesis inhibitor, into a specific brain areas where the consolidation takes place. So we did not allow consolidation to take place. And after that, we recorded a sleep architecture. You can see the vehicle group. There's a vehicle group and N-isomycin group. Vehicle group, REM sleep is high on the training and testing day, but in N-isomycin group is low. So REM sleep did not go up significantly after a training if we impair the memory consolidation mechanism. So the change in sleep architecture was associated with the memory consolidation mechanism. So that proves that when we learn certain aspects of learning where sleep is a demand of the system. So if you don't get sleep properly, means memory is going to be not consolidated in your system and you may have some problem. To address that, what we did another group, we deprived animal to sleep immediately after training, and not too long, only for 6 hours. Immediately after training, this is what I'm pointing it out. So we have divided animal into sleep-deprived group, stress control group, and non-deprived group. So a stress, a kind of a stress, mild stress we applied. And you can see here, these are the different phases. This is the phase where animal was given juice. So non-sleep deprived group and a stress control group, the number of head entries was significantly high, but in sleep-deprived group, it was significantly low. So all these results suggest that when we learn certain kind of associative task, our sleep parameter changes, we go more into REM sleep, and if we don't allow memory to get consolidated, then sleep is not changing. And if we are not getting sleep on that day, on that night, even after training, memory is not going to be consolidated. This is another example of, is called fear conditioning. It's a human model, an animal model is equivalent to the post-traumatic stress disorder. I don't know how many of you are aware of. So the post-traumatic stress disorder, when we encounter any accident or bad events that happens in our life, so some clue that we memorize it, next time when the same clue you see, you get a panic attack that you are going to get the same event encountered in your life. Especially pregnant women are suffering from PTSD after giving birth a child because of the labor pain. Army men, due to siren and gunshot or bombing, they get this kind of panic attack when they lead a normal life. So animal model, this is fear conditioning. So we did the same kind of experiment. I'm showing you two different models. One was related to the positive learning. This is about the negative learning. So this is a video I will learn. So here what we do, we give a tone for 5 seconds, and at the end of the 5 seconds, shock is given. So shock, animal learns, when you next day you give tone, animal learns that they're going to get a shock. The same example, the broken switch. So just watch this video. So when this purple ball will reach near to this area, the tone will be on. I hope there will be a speaker here. And then shock, you will see the rat jumping, only for less than a second. I hope I'm not taking that much of time. I'm on time. Yeah? Left? Oh, I may be finishing on time. So now tone will be on. Oh, the speaker is not working. So the rat jumping was shot and 5 second tone was given. And after that, okay, very interesting thing. We did a very simple experiment. This kind of training we give in the night as well as during the day. And we found in rat, that rat learns better in night than day. So this is what the difference here is, day and night. So rat is a nocturnal animal. They are more active during night. so they learn better. Similarly, human, they are not nocturnal. We may learn better during day than night. I want to remind this thing to the student, what you are doing during the examination period. You are learning more during night and reading less during daytime. No, I do not know. This is a misconcept. Okay. And after giving this kind of training, you can see here the trained animal on the testing and training day, here REM sleep was significantly low. And non-REM sleep amount was more during second, third, and fourth hour. So this is not only augmenting REM sleep rather is low, and non-REM sleep is more. So this says that different kind of learning form, you may need sometimes more REM sleep, sometimes more non-REM sleep. So that is one thing that's important. Again, with the anosomycin, when we impaired learning, REM sleep did not change in an anosomycin group. Vehicle group, it was significantly low, as we found that. And with sleep deprivation, again we found the sleep-deprived animal, the freezing is a response of fear. When we also get scared, first initial thing, we freeze, we don't move. So animal, we record freezing as a parameter of learning. So the freezing response in sleep-deprived animal was significantly low compared to the stress control and non-sleep deprived animal. So all these data suggest that sleep architecture changes during memory consolidation of associative and conditioned memory. Total sleep deprivation impairs memory consolidation. The mechanism of memory consolidation is sleep dependent and not associated with the sleep deprivation mediated stress that we have done for the first time. And sleep may be playing an instructive role in memory consolidation by activating the expression of protein synthesis or gene, because anosomycin is impairing the memory consolidation part. Thank you so much for your patience. And I must acknowledge my real hero. They are my student. They have done all this wonderful work. Thank you so much.
Yep, very exciting.
That's why the major accidents in the world, Chernobyl, or whatever you talk about, major plane accidents or train accidents, that has happened during
even earthquakes.
Nature doesn't know that.
Thank you very much.
Thank you so much.